So tonight we review our exponent rules that we learned in algebra class. So we'll start with our basic rule. If I have some number a raised to the m, or some variable a raised to the m, I multiply a by itself m times. So exponents just mean repeated multiplication. What I'll do for these notes is box in the rule, and then we'll do some practice problems together. So that means x cubed just means x multiplied by itself 3 times. X times x times x. Negative 2 all to the fourth is negative 2 multiplied by itself 4 times. So negative 2 times negative 2 times negative 2. You can do that math out if you choose. That's 16. At this point, I really just want you to recognize the exponent rules. Be careful with the last one. Only 2 is raised to the fourth, and following PEMDAS, I'll raise 2 to the fourth first and then negate my answer. So be really careful with PEMDAS when you're doing your exponent rules. Don't rush. So here this is negative, and then 2 to the fourth. 2 multiplied by itself 4 times. So it's negative 2 times 2 times 2 times 2, which is negative 16. Our next rule reminds us what to do when we are multiplying with like bases. When we're multiplying with like bases, we add our exponents. So a to the m times a to the n is a to the m plus n. That's our next rule. So to practice, I have x squared times x cubed. That'll be x to the 2 plus 3, or x to the 5th. Our next example is really 3 to the first times 3 to the x. My like base is 3. I add my exponents 1 plus x. I can't combine them, so I'm done. My last example, I have like bases of negative 2. So I raise negative 2, add my exponents to the 5 plus third, which is negative 2, all to the 8th. Our third rule is our negative exponent rule. When I have a negative exponent, you want to think fraction, or even more importantly, reciprocal. So a to the negative m is 1 over a to the m. Likewise, a to the positive m is equal to 1 over a to the negative m. That's our next rule. So if I have x to the negative 2, that's 1 over x squared. If I have x to the third, that's 1 over x to the negative 3. So for some reason you needed to move an exponent and make it negative, it goes to the other side of the fraction. 2 to the negative 2 is 1 over 2 squared. Again, you don't have to clean those up tonight, that is 1/4. And 2x to the negative 4, only x is raised to the negative 4, so 2 stays put, and x to the fourth goes to the bottom of your fraction. That's 2 over x to the fourth. Our next rule reminds us what to do when I have an exponent raised to an exponent. In that case, we multiply them. So a to the m raised to the n is equal to a to the m times n. So x squared raised to the third is equal to x to the 2 times 3, which is x to the 6th. X to the 2/3 raised to the 3/7 is x to the 2/3 times 3/7, which is x to the 2/7. Our next rule is our zero exponent rule. You need to remember that any number raised to the 0 is equal to 1. Anything raised to the 0 is equal to 1. So 5 to the 0 is just 1. X to the 0, 1. Negative 3 to the 0, again with PEMDAS, only 3 is raised to the 0, so I do that first and get 1 and then negate it. So that's negative 1. And the final example on your notes is 2x all raised to the 0. That is also 1. So it's really important that you remember anything raised to the 0 power is equal to 1. I will often give students a really big, crazy looking fraction. It doesn't matter what it is. I can write anything in there. But when it's all raised to the 0 power, just remember that it's equal to 1. Don't panic. Anything to the 0 is equal to 1. I promise half of you the first time I give you that, we'll try to simplify everything inside. Don't waste your time. Anything to the 0 is 1. Our next rule is a reminder that math is consistent. When I had like bases and was multiplying, I added exponents. So here I have like bases and I'm dividing, I subtract exponents. A to the m divided by a to the n is a to the m minus n. So x to the 6th divided by x to the 4th is x to the 6th minus 4, or x squared. And x squared divided by x to the negative 5th is x to the 2nd minus negative 5, or x to the 2 plus 5, which is x to the 7th. This is our last row for tonight. The final 2 rules we'll do later in our year. Here I have AB all raised to the m. Because I'm multiplying inside, not adding or subtracting, that m pushes through to everything inside. So AB all to the m is equal to a to the m times b to the m. So xy all to the 3rd is equal to x to the 3rd times y to the 3rd. X cubed y squared all to the 4th is equal to x cubed to the 4th times y squared to the 4th. Now I use my power rule and multiply those exponents. So that's x to the 3 times 4 times y to the 2 times 4, or x to the 12th, y to the 8th. And 2x all cubed is equal to 2 cubed times x cubed, or 8x cubed. Once again, math is consistent. There I was multiplying and raising everything to an exponent. When I divide, everything will be raised to the exponent again. So a over b to the m is a to the m over b to the m. So 2x over y all cubed is 2x all cubed over y cubed, which is 8x cubed over y cubed. 2 cubed is 8, you'll see that a lot. Finally, I have 2x over y to the negative 3rd. Well, remember earlier, a negative exponent means a reciprocal. So we'll do that first, and we have y over 2x all to the positive 3rd. Now I raise everything inside to that 3rd, and I get y to the 3rd over 2x all to the 3rd, or y to the 3rd over 8x to the 3rd. So again, make sure you have all of the rules and examples. This is a foldable that we'll put permanently in your cumulative notes tomorrow. I'll show you how in class, but I wanted you to get the rules and the examples first. Pause if you need to, copy everything down. Otherwise, have a great night.